Welcome back, campers. Rise and shine. Good morning. Welcome back to Old Man and the Sea Sharp. This lesson is going to be on function returns and cross-function communication and a few things kind of in that vein. We're going to get some related things in there to kind of go along with last night's in-person celebration. If you couldn't make it to the people at home, we'll do a digital version later tonight, Sunday night. So this is Sunday morning, first lesson. So let's get right down to it. Okay, so this is just where we left off. We're going to go into return values and cross communication, which is going to help us talk to Unity and various other things, other scripts, things like that. But just let's start doing some cross communication within the script we already have. Good old hello ants, and we'll see what we can get going with that. So one of the things that we do, I just moved this function up off camera, but otherwise this code should be identical. It used to be down here somewhere. So one of the things we do is we increment the score by 1 every time you hit the space bar. Now maybe we don't want it to increment by 1, maybe we want it to increment by some other amount. So let's quickly add a variable for that, public int score increment amount. Now, if we pop over to Unity, score increment amount, let's make that 1. Now, down here where we increment your score by 1, why don't we change this to the fancy one? Plus equals score increment amount, right? That makes sense, right? So now nothing's changed. The logic's all the same. We're just going to increment the score by our standard score amount. That's fine. That's just a setup. Let's talk about return values now. Now, we've been doing some return values already. Remember, functions can return something optionally. Void is return nothing. It just does a thing. So increment score, it increments the score, it prints some messages, but it doesn't return a value back. But if we scroll down to some of these functions we wrote yesterday, like was key pressed, returns a Boolean. So you have to use the return word. If you don't put the return word in there, it'll start complaining on you. See, it gets little red squigglies, and if you mouse over, it says, we're not returning a value, right? So if you say you're going to return anything other than void, you have to return something. We also use, I think we have another one, don't we? Yeah, here's 2 more. Is out of time and has 1. These are 2 functions. They return Boolean values. Now, we're not restricted to Boolean values. We can return anything, any data type at all. So like we could say, get my name, and we can return Billy, because Billy's the first name that sprung to my mind. Or for all the people home looking for my number, right? We can do a phone. Why is that bad? because a phone number has too many digits in it. There we go. So we can return numbers, and we can return strings, and we can return other values, but we don't have to return strict values, because these 2 functions are kind of pointless. Like we could do it the same as like the win message or the score increment amount we just did. We could fill them in Unity. Like, why do we have a whole function dedicated to just getting a static value back? Because the values don't have to be static. That's the thing. So let's show by example. Let's get rid of these, and let's instead, you know what, this function increment score, why don't we make a new function We're going to say score equals calculate new score. Calculate, did I spell that right? Yeah, I did. Okay. Okay, so it's complaining because we don't have a function named calculate new score. Now we know that score, if we mouse over, it'll tell you it's an int, but we can also just look up here and see that score is an int. So we know that calculate new score must return an int as a result. So let's type int calculate new score. And we know that the new score, because we just had it a second ago, new score equals score plus score increment amount. Oh, and it's still complaining, still has the red squigglies because I forgot to write return. There we go. So now we have a function that calculates the new score. Whoops. No, I did this wrong. No. There, that's what I meant to say. I said score equals. Yeah, see, did you spot that? Here, I'll undo. You see the error there? So I said score equals calculate new score. Calculate new score is score equals score plus score increment amount. So we just want the score to equal score plus score increment amount. There we go. Now that reads better. See, it's these little mistakes, right? These little typos that even I'm making right now. These are the kinds of bugs that we run into all the time. It's just a matter of time of, like, the severity of the bug usually relies on how long passed between when you made the bug and when you discovered the bug, and then, you know, all the things that mess up in between. So it's good to catch them as quickly as possible. So the score equals calculate new score, and this just returns what it was before. So we haven't actually improved or changed anything. Oh, I remember. Arguments was the other thing that I meant to say was on our agenda today. So let's get to that. So why don't we complicate this a little bit just to show off the power of arguments and return values. Because there's no reason to have this function right now when what we had before was perfectly fine. Let's make calculate new score, calculate any new score, not just add to our current score. So we're going to do that by adding an argument. I'm going to call it, so this is what the parentheses are for. Remember way back in lesson 1, I said I'll get to why all these functions have these parentheses next to them. This is why. They're there to hold arguments. So you can pass in options. They're called arguments, but you can pass options into your functions and then do things with them. So for example, you have to give them a type. Each option needs a type. So I'm going to give it an option of an integer, and the option is going to be change amount. And then there we go. So now I'm going to calculate the new score as your current score plus the change amount that you supply to the function. Now, as soon as I set this up, you notice that down here, it put a red squiggly on our function call. And if you mouse over it, it'll tell you why. It's because we're not supplying the value it's expecting. So now inside these braces, we need to give it a number. So we could give it a 1, and now it's happy. So now we know that score is going to equal calculate new score and increment the value by 1. So now this is really handy because, you know, in different gameplay events, we can give it -1 to decrease your score. So now we have the ability to increase or decrease, or let's say you have a bonus round and we can increase by 5, you know. So now we have a function that can modify a value kind of dynamically based on whatever it is we want to happen in the code without having to write out, you know, score equals score plus every single time. So kind of useful there. But we know the value we want to calculate the new score from. And that value is going to be the score increment amount. Because we define the score increment amount in Unity, which is right here, this one that we set up earlier. We just have it set to 1 right now, right? So this shows you how you can take in a number and you can return another number based on that. I shouldn't have used the word score because now I'm going to show another example with points that's a little bit more complicated, right? Calculate. I'm going to call them victory points because we want to calculate victory points. Because we want to help distinguish between score and points, which are very different. Score is your current incrementing spacebar count, and your victory points is your high score you get at the end of the level. So let's do the same thing with that and try to think ahead on how you would do this at home as well. So we can see here when you increment the score, if you've won the game, we calculate your points with this right here. So instead of calculating it here, I'm just going to cut and paste this up here just temporarily. It's not doing anything right now. And then I'm going to say calculate victory points. So now points equals calculate victory points, and then we debug log. You know what? We don't even need points equals now. Why don't we just paste it right into here? Then we've just saved ourselves a line of code. So now it's win message plus calculate victory points. So I'll just take 2 and stick them together. It's a string because win message is a string. So calculate victory points. What is calculate victory points? Well, it's going to return the same value it was before, which if you remember last episode, it's your current number of spacebar presses multiplied by the amount of time you have left, multiplied by a magic number, 30. So anytime you have, it's called a magic number. Oh, forgot the semicolon. Programmers call numbers magic numbers when somewhere, wait, why is this? Oh, because I told it to return an integer and the round function returns a float because you can round a fraction to a whole number. There's actually a shortcut that you can use. It's called round to int, which will solve that problem. So you see it makes sure you're always returning the right type. Okay, so magic numbers. Magic numbers are where somewhere in your code you have a number that's just defined, like this one right here, 30. So now if anyone comes along this game years down the road and they're like, how was those points calculated? What does it mean? It's just magic, don't worry about it. It's 30, it's times 30, that's it, right? So a nice thing to do with magic numbers sitting here in your code is instead to bump them up as an exposed value like everything else is. Kind of like the win message and the lose message, right? And now we just have score multiplier. And then if we pop over to Unity, so you have score multiplier in here, we can set that to 30, and now it's the same as it was before, but now if someone wants to come along, or if you want to come along down the road and tune the game to have a different score output, you can now just change this multiplier right here. Nice and easy, right? But let's go a step further. Instead of calculate victory points, just taking score and time left from, from up here, why don't we supply calculate victory points with the actual data that it needs to operate? So I'm going to make an int called base score, and I'm going to make a float called the first multiplier. There we go. So now this function now takes 2 arguments. And instead of just taking your score, I'll do base score. Instead of taking a multiplier, put that multiplier in there. So you do base score times the multiplier times the overall score multiplier. And now where we call calculate victory points down here, you see it's put the red squigglies because now we need to give it those values. So we could say calculate victory points, and that'll be our score and our time left. In fact, to make it less confusing, our score is going to be, or our, is it score? No, it's our victory points equals this. Let's break that back out. I just moved it into there, now I'm just moving it right back out again. There we go. So you can see our victory points equals calculate victory points based on our score and our time left. Now, why do that? Like you may be confused, like, wasn't it working perfectly fine before? I've just now done a whole bunch of typing without actually adding anything, you know? And now every time I call victory points, I have to like pull out these 2 values, right? And all, like, why did I do this? Well, the reason is now this function here, calculate victory points, it now works with just about anything, right? We've made it generic. It doesn't rely on score and it doesn't rely on time left. So down the road, if we want to add a new value, like if we want to add like a bonus or a power up or anything like that, we can just say, you know, score plus bonus. We can say time left divided by 2, right? And we can start modifying and changing how that score is calculated, and that will end up influencing the score, your final victory points, in a much more extendable, easy to use way. So one of the things you want to do as a professional programmer is you want to be able to create functions where you pass in all of the values that it needs to operate, because that means that function can then be cut and paste really easily elsewhere in the code. To give you an example of that, this function here, calculate new score. Actually, both of these functions, but I'll fix one of them in a second. So calculate new score is really, really simple. You pass in change amount, it takes your existing score and changes it. Easy, you're just adding 2 numbers, really, really simple function. It's kind of dumb. But you can't cut and paste this to any other bit of code, because any other bit of code might not have this score value in it, right? So if I cut and paste this, like I'll just make a new file real quick, just demonstrate this. Create a new C# script called duml script. I really wish I could increase the display resolution of Unity for these things. Okay, so now I have a new script called duml script, and if I paste that function that I so nicely, eloquently created, you can see it's already complaining because it doesn't know what score is. Like, what's score? Like, how is it? So now this code is nice and encapsulated, but it's not fully encapsulated. It still has a reliance on that score value. So we can fix that by saying you have to feed it a start amount and a change amount, and it will give you the result. And if I cut and paste that, so now calculate new score. Right now it's just simply adding the 2 numbers together, and here in calculate new score, right? So now if I cut and paste this to the other file, replace this one's fine. So this code will now literally work anywhere, because you made sure that everything this function needs to run is supplied to it right here in the arguments, right? You've given it all of the data it needs to operate, and it doesn't need anything else. Like, there's no references to any other data in here. So now this little function is just, you could wrap a bow on it and you can put it into any game on the whole planet that uses C# anyway, and it will work. Now, This one's, again, it's really simple. It's just adding two numbers together. Maybe this is a dumb waste of time, but imagine a function that's way more complicated that you could then copy and paste everywhere else, right? So this is also called kind of scope or context, because these two variables are all it needs in the scope or in the context to operate, and you have to feed in these values to make it work. But you can get complicated. You can get complex in here. You don't have to just feed in numbers. You can say, like for example, I'll get fancy with this one. Let's make this return a float, right? So that we can return a fraction optionally. And let's say base score first multiplier, float second multiplier, bool round result. Now this is getting long. I'm going to zoom out real quick. I know it's harder to read, but okay, so now this function takes four options, four different arguments: the base score, a first multiplier, a second multiplier, and a bool round result. So now that we're returning a float, I'll zoom back in. Let's break this down a little bit. I'm going to declare a float as my result. The result will be equal to the base score to start. Then I'm going to say the result, oh, here's the thing I didn't show you before, times equals first multiplier. Multiplier. This is the equivalent of saying result equals result times first multiplier. You see, like just repeating yourself, result equals result all the time, is kind of annoying. So we've got the shortcut result times equals. And then we can say result times equals the second multiplier. And then we could say, because we have the bool for should we round or not, we could say if round result, then result equals a rounded version of itself. And then all we have to do is return the result. Now, sometimes Visual Studio puts little red marks on there just to let you know you have some red squiggle somewhere in this file. Before I scroll down, do you know what it is? Can you guess? Can you guess what it might be? What's the error? What did we do wrong? Well, it's an easy one. We've changed the number of arguments that calculate victory points takes. So we now have to feed in more arguments. We were just supplying 2, now we have to supply 4, right? So let's scroll down. Increment score, our victory points, which is now float, equals calculate victory points. We're going to feed it. You know what? It'll give you some hints. So let me show you what the hints look like. Let me scroll over here. So you type your first parenthesis and you're sitting there waiting and you're like, wait, what was I supposed to supply it again? Because it scrolled off the screen. Like what options is it looking for? This is why it pops up. I know it's super tiny on this video, but you could see it writes right in here. It says, I was pointing at the screen. See right where I'm pointing. Hello, and it's calculate victory points, and it says it's looking for a base score. Okay, so you type your base score, it's just your score, comma, and now it bolds the next thing. First multiplier. What do we want to multiply it by first? And we want to multiply it by your time lift. You hit comma, and it bolds the next thing. It's looking for the second multiplier. Now, the second multiplier is our arbitrary score multiplier that we set up in the Unity display. And then comma. And now it says, do we want to round the result? And I want to say true. Yes, I do. There we go. So now we could see we're supplying all of the data that Calculate Victory Points needs to display our result to screen. And now, again, like if I scroll back up here, like the first example, if I grab this function and I cut and paste it to our DOML script, delete this old one, no red squiggles, because now our calculate victory points function can now be copied and pasted into any game that we make in the future with any arbitrary base score, multipliers, round the result, you know. So now we have, you might call this a utility function. Yeah, like it's just kind of an idea of what you can do with return values and what you can do with arguments. So this is why my function, this is why there's always these empty parentheses all over the place in the code. And if we go back to the original code, you see here in our update function, remember our nice easy to read update function? It has no arguments here. That's because it doesn't return anything and it doesn't take any options. It just runs, right? And same thing for our is out of time function, doesn't take any options. And if we scroll up, sure enough, is out of time takes no options, right? And we could change that. Like we could say is out of time, we could say float like time, and then we can, now we need to provide it down here, right? So we can make it accept options, but it's not necessary in every case. Like maybe this is an overcomplication. Maybe this makes it harder to read. Maybe we don't want to do this. Like I said before, there, undid that. In programming, there's usually like 17 ways to do the thing, and how you pick which option you want to take, what path you want to take, it can be readability, legibility, that can guide your decision. So that's the decision I took here for this update function. I wanted to make it as readable and as approachable and as understandable as possible, so that's why I made the choices I did. If you're getting deep into it and the game's running super slow and you want to focus on performance, there's different paths you can take. And if you're writing like a library that you want to reuse for all your games moving into the future, maybe you want to make things similar to this calculate victory points function, so that it's more reusable and more extendable into the future at the cost of it looking a little bit more complicated, right? There's a little more things you have to hold in your head. But I think you'll find as you grow as a programmer, as you start learning more and more, you'll start making more and more functions look like this. You're going to make it look more like something that you feed a bunch of options into, because even though this update loop looks nice and readable, to a seasoned programmer, it might actually look too simple. It might actually seem like almost kind of like silly in how simple it is, because it's so easy to follow. So if you're used to the syntax, this is maybe going too far down the readability path. But if it's just you looking at your code and it's just you learning, it's better to do it in a way that you can understand and then you can work with going forward, right? So let's scroll back up to the top of the file because I forget what I was going to talk about next. Right, so we talked about return values. So a function can return any data type. It's pretty much unlimited. It's just limited by your imagination. And we discussed arguments or options that you feed into a function, right? So we covered that. But now we're going to talk about cross communication. So those last two things are kind of required understanding before we talk about cross communication. So cross communication is when you have two different scripts, like I do here. I have DOML script and I have hello ants, and I want them to talk to each other. Now, why would you do that? A lot of beginners to programming, they actually put all of their code into one file, right? And I was going to say there's nothing wrong with that. When you're learning and you're just starting out, just to keep things simple, that might be your instinct, and that's fine. It's not technically bad. It just might get confusing. because the longer your file is, the more you have to kind of hold in your head about where things are and what's calling what and what depends on what. It's good form to split your program into as many distinct files as possible, particularly if your functions are like our calculate victory point function, where they don't need anything else, right? Like they don't need all of this other hullabaloo. They don't need win messages and lose messages, and they don't care about the time or anything like that. Your calculate victory points is fully self-contained. It doesn't need to sit in the same file as everything else. But we still need the files to talk to each other because we still need to use that. So let's show what that looks like by example. So this is, let's keep duml script. You should probably name the scripts a little bit better than what I'm naming them in this example. But I'm going to leave our, just because it's here, I didn't plan this, I'm going to leave our calculate victory points here in our duml script. And I'm going to open up our hello ants again. And I'm going to remove our identical code here for calculate victory points. Just delete that, right? And you know what? This calculate new score, I'm going to leave. I'm going to leave it here. Actually, I don't want to do that. Okay, so now our calculate victory points only exists in duml script, and our old stalwart hello ants has no way to calculate victory points. And you can see here, it's actually complaining, calculate victory points. It's like, what's that? I can't find it. Where is it? So there's, again, several ways to get to it, but there's one thing we have to take care of first. Do you remember permissions? Calculate victory points doesn't have anything written in front of it, so this is the equivalent of private. Private means other scripts can't access it. We don't want that. We want to access it, so we need to name it public. Public allows other scripts to access that value. Now, how do we access that value? How do we, like if we go back to hello ants, like it doesn't just magically know the name of your duml script. And your instinct might be to just write duml script dot calculate victory points. And that could work. Here's a pro tip. I'm going to show you a trick that you shouldn't do at this stage in your career. But you can add a second property here called static. And you can see the red squiggly went away. Duml script dot calculate victory points totally works. Nice. But static things, they're a little complicated. I don't want to get into how they work, but basically, if you have a function that doesn't rely on any external data because we're feeding in all of it, all it requires is fed in the options. Those functions are candidates to be static, which means they can be called from anywhere in the world, anywhere in your code base at any time. It doesn't matter because everything you feed into it is, it's deterministic. It doesn't matter when or how or what you call it with. It will always return the same result. And because of that, we can name the function static, which means we can easily access it in that way. I'm going to show you the harder way, though, because the non-static way, because that will work with other functions as well, and it'll show you how to interact with other elements in Unity. So I just removed the word static. You pop back to hello ants, and it's throwing an error. We can't even. So what we need to do is we need to find a way to get access to this script. And I'm going to do it like this. I'm going to make a new public variable called our score calculator, our score calculator. Then I'm going to say our score calculator dot calculate victory points. Now this is just a variable. Our score calculator isn't defined anywhere. In fact, I didn't give it a type. What is the type of our score calculator? Can you make a guess? I'll give you a hint. It's on this screen. the type of our score calculator is going to be dumb ol script. The class name is the type that it is, right? So dumb ol script is of type mono behavior, which I showed you in lesson 1. That's the type. Like a string is a type, an int is a type, a float is a type, a mono behavior is a type, dumb ol script is a type. So dumb ol script is the type that contains calculate victory points. So you see, it's a little confusing. I don't want to get too deep into, like object-oriented programming and just know that the file name is the type that you can then declare in your variables here. So if I just say dumb ol script, so now I have a public variable called our score calculator. Its type is dumb ol script. And now down here in our increment score function, we could say our score calculator dot calculate victory points. Now, do you think this will work? I wouldn't blame you if you did think this would work. And there's no red squigglies on our hello ant script, and there's no red squigglies over on our dumb ol script. So you'd think it would run, right? But if we go over to our game here, and we hit play, and I hit spacebar, what is it, 3 times? There we go. Okay, so I got 1, I got 2, everything's working fine, and then when I hit the victory button, null reference exception. Big red error listed in Unity. You'll see these a lot. I get null reference exceptions thousands of times in every project I work on. This is a very common programmer error. It just means you forgot to fill in a blank somewhere. And can you see the blank? Do you know what the blank is? It's here on the screen again. It is, we made a public variable called our score calculator, and you can see it down here. And remember, like every time we set a variable, we had to set 20, we had to set 1, we had to set 3, we had to set 30. We had to type our win message in here, right? But our score calculator, it says none. We haven't filled in this field. We haven't assigned a value to our variable, our score calculator. And you can see, like, we can't type in this field. We can't just type in the name of the script or anything. But what we can do is this object here. We have 2 scripts down here. We only have 1 up here. Why don't we just drag and drop our dumb ol script here onto the game objects. Now we have a dumb ol script sitting here, side by side with hello ants. And we could drag and drop this onto that field, right? You just drag and drop like that. And now we can see, if you click on this, you see it does the yellow highlight. It's highlighting the same object. It doesn't have to be on the same object. You could be coming from somewhere else. But now we have a value. Now we know it's referencing this script. And that's kind of how you link things together in the Unity editor. And now if we hit play, and I hit spacebar 1, 2, 3 times, no error, winner 1566 is my points. Right? Nice. So it works. Now the reason this is really important, and this is kind of critical to teach, is that this is how you would access anything else in the game world. Like, for example, let's say this is our cube that we see fall to the ground at the start of every game. Let's say if you win, that cube blows up, right? It gets destroyed, it disappears from the game. How do we do that? Well, here in Hello Ants, right after where we did our score calculator, we can do a public variable. The variable type is going to be a game object. Now, that's a magic word that Unity invented. And I'm going to call it our cube. some of these things you just have to memorize and get to know or ask somebody. Game object is one of those. Game object is, it describes, it's the type of all of these things here in the top left in the scene view. It's the name for all of the components or all the objects in the world. Components are each of these things. So our game object, this is our, I'm going to give this a name. Let's click on it here. Our script object. So our game object is our script object, and it contains three things. And that's here in the inspector. It contains a transform, which just dictates where it is in the world. It doesn't have any visual representation, so we're just moving nothing. It has a hello ant script, and it has a duml script. But if you click on this cube over here, I'm going to rename this cube the floor because that is the floor. This is the cube. The cube game object has a transform. It has a cube mesh filter. That's the shape of the cube. Because it could be, if you click on this little dot here, you can actually change it to a sphere. So now our cube is a sphere. Like, that's confusing. And the mesh renderer, this is what, so something can have a shape, but it can't be drawn, but it might not be drawn to the screen. So if you just click this checkbox here, there, we have a cube, but now it's invisible. We got a ghost cube. And it also has a box collider. This is what makes it bounce on the floor. It's possible to have things that have a shape, but they don't have substance, so they'll just pass through everything, kind of like a visible ghost. If you turn off the renderer, this green outline is actually showing you the collider, so you'll have a poltergeist, an invisible cube that can still bounce off of things. So these are all different components that do different things. Rigid body, which I added back on lesson 1, all it does is it gives you this checkbox here to add gravity and a few other options. So this is what makes it kind of fall to the floor, because it's possible to have something that has a collider, but it just sits there and floats in the air. Which is what our floor is. Our floor is just solid. If our floor had gravity, our floor would fall to infinity, right? So we want our floor to be solid. So all of these things in the inspector column are components, and all of the things in the scene view are game objects. Let's go back to our script. Here's our hello ant script. Here's our new variable, our cube. And again, it says none, so we'll get another null reference error if we try to access this. So we want to assign this. And we could drag and drop our cube from our scene view down here into the field, and now we have a reference to our cube. There's another way you can do it as well. I just hit delete to erase that reference. You can click that little dot again, and now it'll give you a list. Here's all of the game objects in your assets folder, which we don't have any. And here's all of the game objects in our scene view. So you see, this is just a replication of this list here, right? It's just the same thing. But you can imagine if you had a really big project, you can actually use the search field up here and be like, where's my cube? I know it starts with CU. Yep, there it is. If you just double click on that, it'll populate it in there for you. So a few different ways to do the same thing. There's actually a third way to get objects by code. So you can type in, you can figure out how to add things by typing them in. I probably won't get into that. That's a little advanced. Maybe I'll type it once, so you'll see it once. I'll just make a dumb function. So let's say if we wanted to find our score calculator via code, we'd say get component of type, and then use triangle braces duml script. Get component of type, what? Oh. Game object dot get component of type. What? Why is that? Oh, I'm sorry. See, It's easy to make mistakes. It's not of type. I was saying of type, but you don't actually type of type. It's just get component. So remember I said everything in the inspector is a component? You can just say get component, and then you give it the type that you're looking for, and it'll fill it in for you. So that's how you do it in scripting. Anything you do in script, though, makes it harder to tune and tweak things from the editor, which is really convenient. One of the big powerful tools that Unity gives you. So we're just going to stick to the drag and drop method here in the inspector. So now we have a reference to our cube. This is a long-winded way of saying we want to blow up the cube. We want to make the cube disappear when you win the game, right? Just give a little visual feedback that something's happening. How would we do that? Well, here in the code, we have here's our you've won message, right? And here's where we output that we've won the game. Here we just say our cube, actually, before that, we're just going to destroy our cube. Just that simple. So destroy is another keyword that Unity has added, and all it does is it just emulates as if you hit the delete key. So let's save that, and let's hit play, and let's see what happens here. There's our cube falling down to the ground, spacebar once, twice, boom. Cube disappeared, and there's our victory message. So that's how you affect things in the world. But just blowing up the cube, that's not so interesting. Let's make it, I don't know, what do we want to do? Why don't we launch it into the air with some physics, right? Let's make it, how about every time we add a point, the cube hops? How about that? Then instead of just adding 1, 2 in the console log, how about the cube hops every time? So it kind of gives you this neat little bouncy feeling. Let's do that. So how are we going to do that? So we break it down, make a sandwich, right? How are we going to make the sandwich? We're going to need so anything physics related, you can click on the cube and you can see anything physics related has to do with the rigid body, right? That's the fancy term for physics thing. The rigid body has mass, it has drag, it uses gravity, you know, it has all these different things. But the rigid body is what you can apply a force to. That's what you can push. That's what you can bubble up. That's what you can bounce. So anything that has physics that you want it to move, you have to move it through the rigid body. So for us to make the cube jump, we need a reference to the rigid body on the cube. And thankfully, that's really easy. Go back to our code. We don't want to destroy our cube anymore, so we actually don't need this. Let's rename this to cube physics, and the type we're looking for is rigid body. So now we have a rigid body variable called cube physics. And then down here, we're going to erase this destroy our cube. And anytime we add to our points, we're going to say cube physics. And if you want to know what options are available to you for physics, remember, just hit the period key. And it does this little pop-up and it shows you all the options that you have. Now, some of these might look tempting at first, like velocity. Maybe we just want to add to the velocity. And you can do that, but there's some handy functions here that make it easy, such as add force. I think I want to add force because that's what a jump is, right? A jump is adding force to a cube. So I'm going to add force. Now, I don't know what this add force function wants, so I'm just going to type the open parenthesis, and it does a little pop-up, and it tells me it's looking for a vector 3 called force. Now, I don't have a vector 3 of force, so maybe I'll make one. Vector 3 is one of the, I think last episode I showed you early on as one of the data types. A vector 3 is just a collection of 3 different floats, right? So I'm going to make a new vector 3 called jump force, and I'm just going to set it to 0, right? So now you can see jump force.x equals 0, jump force dot y equals 0, you know, all that kind of stuff. So in Unity, if we look at the scene view here, see the green arrow pointing up, and we look in the top right corner, see the green arrow here, and it says Y. That's telling you that Y is up and down. So Y is the axis that we care about. If we add force to Y, it'll go up. If we add force to Z, it'll move this way. And if we add force to X, the red X, it'll move this way. So we don't want the cube to move left or right or forward or back. We want the cube to go up. So we only care about Y. So jump force is 0. Then we're going to say jump force dot y equals, well, I don't know, 100? Is that a good number? I don't know. And then we just give it this value, jump force. So now cube physics will jump up. In fact, this is a magic number. This is probably a bad idea, right? We learned our lesson for that. So I'm going to make a public variable, a float called jump power. And instead of giving it a number of 100, I'm going to give it a number of jump power. So now we're going to create a vector 3. We're only setting one value of the vector 3, the y value, so it can jump up. And we're going to tell the cube physics to add jump force to it. So every time you get a point, it should jump up. Let's see how that works. Well, we have to do some hookups over here in Unity now. Go back to our scripting object. And we see our jump power is currently 0. Let's crank that up to, I don't know, 100. Maybe that's a good number. So it's hard with physics because it depends on the weight of the cube and the gravity of the world. And, you know, it depends on all these different things. So maybe the jump power isn't what you expect. But that's why we expose it here, because if it doesn't work, it's really easy just to change the number and try again. Now, so I can try multiple times, I'm going to change our goal from a 3 to 20. So I have 20 attempts before it cuts me off. And you'll also notice our cube physics variable, it's none, we'll get a null reference again. We don't want that. So again, we can click on the little dot and it'll tell us all of the rigid bodies in the world. And you can just double click on that. Or you can grab our cube and you can drag and drop it over and drop it off there. And now we have a reference to the rigid body. And that should be all we need. Let's hit the play button and see what happens. There's a cube, it falls down. Let's get a point. Oh, look at that cute little jump. Hop, 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 hop. And if you tap spacebar several times, you get a little bouncy. Look at that. Oh, I won. There we go. So now we've just like influenced, like that's it's kind of adorable how cute. Let's restart. It's kind of adorable how cute the little cube hops up and down, right? Hop, hop, hop. There we go. So now you know, if you're clicking around, let's say we want to show the score to the screen. First, just do a mock-up, right? You right-click here in the scene view. Let's add a 3D or 2D? 3D? I'd normally do text to the screen as a UI, but UI is difficult. So I'm going to add a 3D object called 3D or text Mesh Pro. Text Mesh Pro versus 3D text. 3D text is kind of the built-into Unity thing. Text Mesh Pro requires a plugin that you install. Text Mesh Pro looks better, but we're going to skip it for now because it just complicates, adds extra steps. So I'm just going to add 3D text. And you can see it's added some 3D text to the world here. And is that even visible in the game view? You can see the H up here. So let's move it by, here we go. Here's the text. So you can see the camera is over here to the left and it can only see the H. So we want to move the text over this way. We want to move it up. And it's too big, so I'm going to shrink it down. There's keyboard shortcuts to do all these different things. So I'm kind of cheating here. Now if we switch back to game view, you can see There's our text up there in the sky. Let's lower it down a bit and move it to the left a bit more. There we go. So this text is going to be called points. It's going to be our points display. And you can see here, so our points display has a transform, that's its position and its size. It has a renderer, this is how it draws to the world. Again, you could turn this off just like we did for the cube. You just turn it on and off. And you can see there's also a text mesh. And the text mesh has a text field that says hello world, but we want to mock this up to say like points 9999, something like that, to some garbage value. And we can change around different things. Like we can make the, where's the font size? The font size is currently a 0. Like we can make the font size 20 or make the font size 1,000. And now you can see that the text is just so gigantic that you can't see it. But a common trick is to make the font size like 200, and then you get the scale of the object. Oops, where am I here? Now see, it's too big, and then you just scale it down, make it itty bitty. And the reason why you set the, oh, where'd it go? Oh no. Oh, lower it down a bit more. And the reason why you'd make the font size really big and then scale it smaller is because it makes the edges of the font crisp and nice and neat. It's kind of dumb that Unity does that, but a little trick. And you can see it has a color field in here, and we can set the color to whatever we want and make nice yellow. There we go. Okay, so every time now that the cube does a little hop and we gain a point, we want to change this text to reflect our new point system. So now we have all the tools we need, right? All we need is we need a reference to this text mesh component. And then anytime we increase the score, we just have to change this text field, right? So you plan it out, you lay out all the pieces, you have all the components ready to go in the scene. So let's code it up. Let's go to our Hello Ants project, and we need a reference to a text field. You see there it is. And I'm going to call it the score text. Now if we pop back to Unity and we look at our script object. Oh, I forgot to hit save. Always hit save. Why isn't it showing up? Oh, it's not text field, it's text mesh. I got it wrong. I just read the wrong thing. Yeah, so to confirm, you click on your points text. You're looking for this name right here, the name of the components you want to modify, and it's text mesh, and I typed text field for some reason. Okay, so now if we go back to our scripting object, you see none text mesh. You can click the little doobly-doo, and it knows there's only one in the scene anyway. Let's use that one. Or again, you could just drag and drop your points over into that field. So now we have a reference to the text field. Now we go back to our code. Now we need to modify the text field. Now, it's possible, in fact, I'll show you. How would I show you? So we have our new score calculated. So right about here, we're going to say, wait, what do we call it? Score text. Score text. Now, we can't just say score text equals like a string, because score text is the text mesh. It's the component. We need the bit that controls the actual font display. So we don't know what that's called, so we just type score text, period, and we look for the pop-up that matches what we're looking for. And in this case, the pop-up is text. We also notice a few other fun pop-ups, like maybe we can increase the font sizes. In fact, let's do that, but let's start with text. So our text is going to equal points plus, well, let's call it score. Your score. There we go. And now just give it a quick test, make sure everything's working the same way that you want it to work. Hit play, cube falls. There we go, look at that. Score's increasing as we go. Cube's jumping. Looking good. Now I'm gonna scale down. Scene view, scale, shrink, shrink, shrink. Shrinking the text a little bit because I want to give myself some room so that I can say score text dot font size. Now I'm just going to add to it. I don't know what. 3. Magic number. So I'm just going to guess at 3. Now I could expose this as a, oh, not an F. I'm going to expose this, I could expose this as a variable in the Unity inspector, but I kind of want to just take a stab at this one. And then I'm going to add another fanciness. Here, if you've won, I'm going to say score text dot, get the little pop-up, and color. Let's change the color of it. Equals color dot green if you win. And also, where do you lose? Scroll down here a bit, find out where you lose. Here we go. If you're out of time, score text dot color equals color dot red. There we go. So now we're like if you want to know what you can do with score text, you can just hit period and like see all the different values in there. But you can also just take a look at the text mesh object here in Unity, and anything you see listed here and more will be accessible to you, and you can play around with these dynamically at runtime. So now if we hit play, now we should see once we get to 20 points, bing, turns green, and you'll notice my font size increase of 3 added a little bit of a bump. Boop, boop, boop. See, it's getting slightly bigger every time. It's kind of a cool little effect. This is when you get your art and design friends to go and you know, juice it up and make it look really cool. And if we hit play again and we knock this timer down to 2 seconds, turns red when you lose. Look at that. So now we've got nice visual feedback. We've learned how to link different scripts together. We've learned how to reference any component anywhere in the game world just by drag and dropping. And we learned how to kind of explore the system by saying, you know, score text dot, and then what do we have available? Like, look at all these different things. We could make it left aligned, whatever we want, right? Yeah. There we go. Look at that. So I think what we'll do is, I mean, it's been, the hour's up here on Sunday morning. Sunday afternoon, the next lesson, why don't we take a break for lunch, and then, yeah, the final lesson will just be putting it all together. We'll make something together, make something a bit more gamey than just cube bounce up. Cube float. Maybe we'll play with some physics or some things. But I mean, it's pretty neat how we start from something so simple and we've just slowly expanded it to get more and more and more complex. And now we're definitely at a point where if someone's unfamiliar, someone hasn't sat through this this weekend course, like all of these different things just be overwhelming and seem really weird and like, but we understand, don't we? All right, let's meet up after lunch and let's make a thing together. Stop button.